Hello and welcome to Intermediate Algebra here at Bay College, our online lectures. Today we're going to look at 5.3, complex fractions. And I kind of don't like the word complex fractions. It's not really too complex if we understand what we're actually doing. It's something we should be somewhat familiar with, as we'll see in this example, where we're just dealing with actual numbers, some rational numbers. I like to think of it as more of a multi-story fractions. Okay? So if we look at this, it's 1/3 divided by 2/5. If we simply rewrite that, it's something we are probably familiar with if we haven't seen complex fractions before. It's saying 1/3, the numerator fraction, divided by the denominator fraction, divided by 2/5. And if we recall, when we have 1/3 divided by 2/5, or any rational number divided by another rational number, we can always change it to multiplication by multiplying by its reciprocal. So 2/5, we flip the second fraction to 5/2. And now we can multiply that out. 1/3 times 5/2. That's essentially all this is saying. So it's really not too complex. It's something we've seen before. It's just in another form. So 1/3 divided by 2/5. I can take this and just for shorthand purposes, multiply the top by the reciprocal of the bottom. Multiply by the reciprocal 5/2. So I have 1/3 times 5/2, and I get 5/6 as my answer. So that's not so bad. We know we multiply by the reciprocal when dealing with fractions. So 1/3 is 2/5. There's another method I could also do, and that's look at these denominators. If I multiply the top and the bottom by the LCD, as we've seen in the previous video, section 5.2, that's another method. If I multiply this by the LCD of 3 and 5, which would be 15, 15 times 1/3 is 5. 15 times 2/5 is the same as 3 times 2, which is 6. It gets us the same result, 5/6. And we're going to look at these two different methods, and we're going to apply them to our rational expressions in complex fractions, or multi-story fractions. So here we have 4x, or excuse me, the quantity 4 divided by x, divided by 5 over 2x, these two rational expressions being divided. I can rewrite it, or I can just multiply the top by the reciprocal of the bottom, which would be 2x over 5. So we've dealt with this. Let's just look at this. We can do some simplification here. We have a factor of x on the bottom, a factor of x on the top, so that will reduce to 1. And so I have 4 times 2 is 8. Over 1 times 5, 8/5. So we can leave it just like that. This is our simplified answer to this expression. All right, let's look at some other examples and say, OK, let's look at these two different methods. We're going to use method 1 here, where we can simplify the numerator to a single fraction. Then we'll simplify the denominator to a single fraction, and then multiply by the reciprocal. So here, if we look at this, if I want 3 minus 2x to be a single fraction, we have to find that LCD of the top. Well, the x is my only denominator, so I'm going to multiply this by x over x, that value of 1. So I have 3x over x minus 2 over x. So let's simplify that. 3x minus 2 over the common denominator of x. Now, this finding that common denominator is what we covered in the previous video 5.2. Divided by, well, we got to do the same thing down here. We have two terms. We want to combine it into a single fraction. Well, this denominator is 9x. So we need to multiply this by 9x over 9x. So now they have a common denominator. I multiplied by 9, and x times x is x squared. Now I can write this as a single fraction. I have 9x squared minus 4 over the common denominator of 9x. Now to simplify this, I just multiply by the reciprocal of the denominator. So I'm going to take this and change it into multiplication by taking its reciprocal, which would be 9x over 9x squared minus 4. Now, if we recall in the previous video, when we have multiple, or 2 videos prior to this one, when we have multiplication of rational expressions, we want to factor and reduce. Well, this factor is, hopefully we recognize it as the difference of squares. So it's going to factor to 3x minus 2 and 3x plus 2. And we can see, hey, we have a common factor, 3x minus 2, 3x minus 2. We can reduce that common factor to 1. I have an x in the denominator, an x in the numerator. We can reduce that to 1. Essentially, look, this actually reduced to 1. Essentially, our answer is here. We just have to put it all together. I have a 9 in my numerator and a 3x plus 2 in my denominator. This is the simplified version. And now, let's just kind of step back for a moment and review what we just did. We took the top, wrote it as a single fraction by combining these to have the same denominator. We did the same thing in the bottom to make it a single fraction in the denominator of our larger complex fraction. And then we multiplied by the reciprocal. We factored and reduced. Now we're going to do the same thing here. The top is already a single fraction, so there's nothing to do there. Let's look at our denominator. Well, we have 2 fractions in our denominator here. We want to combine it to a single fraction. So I look at this and say, well, the factors I need, y squared over y squared. Here I need the factor x squared over x squared. And we can look at our denominators now and say x squared, y squared, x squared, y squared. We have a common denominator. So we can go ahead and write this to have the same denominator. Y squared times 1 is y squared, plus 1 times x squared is x squared over that common denominator, x squared, y squared. And now that we've simplified this to a fraction divided by a fraction, we can multiply by the reciprocal of the bottom, multiply by the reciprocal of this, x squared, y squared over y squared plus x squared. So we've dealt with that. Now we just have to look at this. Now, because we're just multiplying rational expressions, we can reduce any common factors. If I have 2 x's on top, it can reduce this factor of x on the bottom. So one of these x can reduce that 1x. Now, if we look at this, this is 1 over 1, because it did reduce to 1. 1 times anything doesn't change it. So essentially, our answer is what's left here. Let's just rewrite it to clean it up. I have 1x on top, a y squared on top, and the y squared plus x squared on the bottom. Now, because this is 2 separate terms, we can't do any canceling here. These do not cancel. This is where we stop. All right? There's no rules of exponents that deal with addition or subtraction of terms. Okay? Only multiplication. All right, let's look at method 2. We're going to look at the same 3 examples that we just seen, and we're going to essentially look for the common denominator of all the fractions involved and multiply top and bottom and simplify. So this is actually my preferred method. Instead of simplifying the numerator, then simplifying the denominator, then multiplying by the reciprocal, we're essentially just going to find the LCD of all the fractions, multiply all the terms by that LCD, and it, in many cases, will simplify itself as we go. So if I look at this example, we have an x in a denominator here. We have a 2x in the denominator there. Our common denominator is 2x. So I'm going to multiply 2x times the top and 2x times the bottom. Essentially, 2x, top and bottom, I'm multiplying by 1. Let me just get this out of the way here. So if I'm multiplying by 1, I'm actually not changing its value. So let's simplify. 2x times 4 over x. These x's will cancel. We have essentially 1 in the numerator and 1 in the denominator. As a common factor, they'll cancel. So all that's left here is 2 times 4, which is 8. Here, 2x times the quantity 5 over 2x. Well, our 2 x's cancel. They are a common factor, and that leaves me with 1 times 5, which is just 5. Now, maybe you can see that this was actually a few less steps than combining the numerator, combining the denominator, and then multiplying by the reciprocal. By multiplying by the LCD, top and bottom, it reduced itself right to the answer. 8/5 is it. That's as far as we have to go. Now you'll see that the second method can actually save us a few steps when it comes to even more complex fractions. Here we have 3 minus 2 divided by x divided by the quantity x minus 4 over 9x. What is our LCD? Well, we have an x in a denominator here. We have a 9x in the denominator here. Our common denominator of all the fractions involved is 9x. So I'm going to multiply the top by 9x and the bottom by 9x. Now we can see, because we have more than just one term here. In the previous example, there was only one term, but here there's two terms. So we need to distribute. If I distribute 9x times 3, I'm going to get 27x. 9x times negative 2 over x. Well, 9x times this quantity, the x's will cancel. And I'm left with 9 times 2, which would give me negative 18. That is my numerator. Now I distribute this 9x to the bottom. 9x times x is 9x squared. And 9x times 4 over 9x, well, 9x cancels the 9x, leaving me with just minus 4. So we come to this here. Notice this is a single fraction. It's no longer complex. But we still always have to check, can we reduce this? And we reduce these rational expressions by essentially factoring and canceling any common factors. So I look at these and say, hey, I can factor a 9 out of here. And that's going to leave me with 3x minus 2. And I look at this and I recognize this as the difference of squares. 9x squared is a perfect square of 3x, and 4 is a perfect square of 2. So 3x minus 2, 3x plus 2. And now that we factor, we can say, hey, we have a common factor, top and bottom. And if we reduce that, our final simplified answer is going to be 9, the only factor remaining on top, over 3x plus 2, the factor remaining on the bottom. So this is our simplified expression, 9 over 3x plus 2. All right, let's look at this next example. We're going to apply that same concept, method 2, which is determining what the LCD of all the fractions are. Well, I have an x in the denominator. I have an x squared in a denominator, and a y squared in the denominator. So I'm just going to write, what is my LCD? Well, I need 2 factors of x. This one only has 1. It's going to need 2. Those 2. This has 2 factors of y. None of the others have that 2 factors of y. So I need 2 factors of y. This is my LCD. If I multiply all the terms by this value, we're going to have a simple fraction, not a complex or multi-storied fraction. So I'm going to multiply by x squared, y squared over x squared, y squared. And because we do have addition here, we have to use the distributive property. Well, here, x squared, y squared times 1 over x, one of the x's will cancel. And that's going to leave me with x y squared. If I just cancel one of the x's, this cancels one of those. xy squared times 1, xy squared. Here, if I distribute x squared, y squared times this value, the x squareds cancel. So I have y squared times 1. If I distribute it to this term, the y squareds cancel, or reduce to 1. X squared times 1 is just x squared. Don't forget that that's addition. We're distributing. So we have x y squared over y squared plus x squared. Notice that we've come to the simplified answer. There's no more simplifying we can do. I can't factor anything out of this, so it's not going to cancel anything on top. So we notice we multiply by the LCD, and it actually simplifies the equation. All right, one last example. This was a very short section, 5.3. What if we have negative powers? Well, if we recall our rules of exponents, this just means the reciprocal of x squared, that negative power. So I'm just going to rewrite it. It is 5 over the reciprocal of x squared. So x squared goes in the denominator. Here, it's minus 3 times the reciprocal of y, which would be 3 over y. Reciprocal rule of exponents says we can move it to the denominator and change the sign of the power. Hopefully we remember that. In the denominator, I have the reciprocal of x, which is 1 over x, plus the reciprocal of y, which is 1 over y. So now we've rewritten it as a complex fraction. Negative exponents are nothing more than fractions. We have to move things to the denominator. So now we can use method 2 and we can assess this. I can say, what is the LCD of all my fractions? I have 2 factors of x, 1 factor of y. So we have to have 2 factors of x, 1 factor of y. X squared is my 2 factors of x. Y is my single factor of y. I'm going to multiply that LCD by the top 2 terms and the bottom 2 terms. So I have to distribute. If I distribute x squared times y, the x squareds are going to cancel. So I have y times 5, which is 5y. If I distribute it to the next term, the y's are going to cancel. So I have x squared times a negative 3, negative 3x squared. Distribute the LCD through the bottom, x squared times y, or times the quantity 1 over x. One of the x's cancel, which leaves me with 1x and 1y times the 1, the numerator. And if I distribute that to the 1 over y, the y's are going to cancel, and it's going to leave me with a positive x squared. Now, we do want to check, can I factor and reduce? I could factor an x out of the denominator here, but I can't factor an x out of the numerator, so it's not going to cancel. So we can stop right there. This is the simplified form. If you did factor this out and seen that it didn't factor, you can leave it in a factored form as well. Either answer is acceptable. Practice these. That's all it takes. In any concept of math is enough practice for you to understand it, and hopefully it becomes second nature over time. And that's what it takes, time and effort. Thank you for watching. This has been section 5.3.